Hello friends, in this video we'll be starting with elementary discrete time signals, and in this particularly we'll focus on unit impulse signal. Let us begin. So let us begin with elementary discrete time signals. Elementary discrete time signals are not different from elementary continuous time signals. They are exactly same. As you can see, of course nature would be different, but name of the elementary signals are remaining same, which are unit impulse, unit step, unit ramp, and exponential signal. Let us start with a very first signal, which is unit impulse signal. Unit impulse signal is designated as del of n. So I can say this is del of n. We know that in discrete signal on time scale, we don't take t. Instead of t, we take this as n. So looking at the signal, now I can write the nature of this unit impulse signal like this. Del of n is equal to 1 at n equal to 0, and this is 0 when n is not equal to 0. So remember, like in continuous time impulse signal, this is also quite similar with minor differences which we will be discussing now. So here, as similar to unit impulse continuous time signal, this is sudden signal or sudden disturbance occurred at 0 time. Is that right? But with finite amplitude this time. In continuous time signal, we used to have infinite amplitude, but unity area. Here, magnitude is equal to 1 and not area equal to 1. Also, we can have generalized impulse signal like this, that is k dot del of n. I can assume any value of k. Let us assume twice of del of n. Then this is a signal present at n equal to 0 having amplitude equal to 2. And then I can draw it like this, present only at n equal to 0 having amplitude equal to 2. So I can write twice of del of n equal to 2 at n equal to 0, and this is 0 when n is not equal to 0. So looking at the nature, it looks quite similar to unit impulse continuous time signal. This is unit impulse discrete time signal. So now we will see what are the differences between them. So here we are going to see the difference between unit impulse continuous time signal and discrete time signal. So I'll talk about continuous time signal here, where unit impulse is designated as del of t, and in discrete time signal, unit impulse signal is designated as del of. Is that right? Remember, magnitude of del of t at t equal to 0 is infinity. If you remember, here magnitude of del of n at n equal to 0 is 1. Is that right? But we used to write area of del of t at t equal to 0 used to be unity, which is 1. So this is the first difference we have seen. There is no area concept in case of discrete time signal. One more important property we have seen for delta t signal, that is area under the curve. So we integrate is equal to 1, because we know that integration gives you area under the curve. Let me tell you, in discrete time signals, there is no place for integration and derivative. So integration in discrete time signal gets replaced by summation. So what we have here is summation. I'll say n equal to minus infinity to infinity. Del of n is always 1. We know that graphical representation of del of n looks like this. So at n equal to 0, we know that amplitude of del of n is unity like this. So in summation, what is happening? I'm taking all values from minus infinity to plus infinity, and I'm trying to add all samples together. We know that there is absolutely no samples present over here, even over here. So sample is present only at n equal to 0, and that is only 1. Therefore, summation of L of n right from n equal to minus infinity to plus infinity is always unity, whereas in case of continuous time signal, we take integration of del of t right from minus infinity to infinity dt is always equal to 1. Similarly, del of n signal is also representable in sequence form. What is meant by sequence form? We'll understand. See, all samples over here, that is at n equal to minus 1, n equal to minus 2 is always 0. So I can say all of them are 0. Only at n equal to 0 we have 1, and all other samples onwards are 0. So infinite samples are there which are 0. Only one sample is there which is non-zero, and that too at n equal to 0. And to say that this one is present at n equal to 0, we show this arrow mark. So this arrow mark indicates n equal to 0 position of del of n. So we have a facility to represent del of n in sequence form. That's not the case in continuous time signal del of t. We cannot represent continuous time signal in sequence form. So these are the basic differences between continuous time impulse signal and discrete time impulse signal, right? One more thing I can tell you about this. In continuous time signal, if we write a times del of n, then what is a? In case of continuous time signal, we don't write n, we write t, right? So we need to correct this. So when I write a dot del of t, we know that what is a is. A is the area of impulse signal. Is that right? But that's not the case in discrete time signal. We have already seen this kind of thing here. When I write k times del of n, k is a magnitude. See, when I write 2 dot del of n, 2 is the magnitude. So remember, a times del of t, a is area, and when I write a times del of n, then here a is a magnitude, or you can say amplitude also. One and the same thing here. So I'm sure now you have understood this unit impulse signal. In next video lecture, we will concentrate on unit step signal. Thank you.